We're almost there. Just past that clearing. What's that look? First time here? Don't worry. Probably nothing you haven't seen before. You know the deal. We go in, observe, get out. Just gotta make sure not to... Ah, here it is. Strigosa Prime. One of the oldest in Romania. In fact, some of our measurements point towards these caves having been formed around 48 to 3000 BC, which makes the fact that the entrance to these caves shows clear signs of having been made artificially pretty interesting. While not at all impossible, it is certainly not consistent with archaeological remains of cultures from the time. Not human cultures, at least. Of course, a lot of the extra bits and pieces were added much later. Ah, yes, you can probably see them by now. What's that? Yeah, Eastern Orthodox. All over the first 2 floors. I'm no expert, but I feel the similarity is astounding. You'd almost believe it was an actual monastery. Just one more along the region. Tricky little bastards, those vamps, aren't they? Don't worry, I don't think there are any left. Famous last words, I know. Anyway, if you'll come with me downstairs... there you go. Thracian architecture, some Dacian too. Did they copy it? Steal it? Don't ask me. But it sure did the trick. So many people fell for it in the past. That's why the area was marked. Careful with those bombs. Yeah, they almost turned the entire Hoya forest into a half cemetery, half breedery. We're lucky none have been seen in over 80 years. Those things must all be dead by now. Oh yeah, look at that skull. One of those things if I ever saw one. What? Heck if I know. These things are so messed inside I wouldn't be surprised if they just fell dead for the heck of it. Anyway, think this is good enough for a survey? Yeah, you know the deal. If we go back now, we'll probably have the report ready by... Wait. Did you hear something? Oh crap. Vampires. They seem to be everywhere, right? And I don't just mean in our world. Even our stories and folklore are filled with them. And, surprisingly, so many of them come from the very same root. This form of vampirism has evolved from a 3-genome system, consisting of a human host infected by a microsymbiont complex formed of a protozoan, Nyctivoe hemolestes, and a retrovirus, the resulting holobiont being termed Homo sapiens morbus hematicus. These microsymbionts are contagious, and can be transmitted through infected blood to a host with a weakened immune system. Upon infection, the human host will undergo irreversible anatomical and physiological remodeling via epigenetic rewriting, a product of retroviral components that integrate into the host genome and the formation of host-integrated remodeling cells, or HIRC, the host's inflammatory responses being suppressed to avoid rejection. This process begins with an atrophy of the internal organs to reduce metabolic demand, their basic function within the host being performed by ciliated linings that replace the smooth endothelium. These cilia are what keeps their thick blood flowing, and the respiratory systems will be reduced until chest movement is largely absent. Primary and secondary sexual characteristics will disappear, and the host will no longer be reproductively viable. The sex of the colony will be, instead, determined by the colonies of microorganisms. This holobiont will reproduce through sporulation, usually initiated after fatal or near-fatal host trauma, or through soil and water-borne cysts. Muscles will be reinforced and the skeleton will develop spores to act as muscular anchorage, while a process of iron mineralization of the trabecular bone will begin, taking place over the course of years or even centuries, greatly increasing the strength and durability of individual colonies. As the body is maintained by this new cellular network, which repairs the DNA and telomeres and reduces oxidative damage, colonies will achieve biological immortality, surviving unless injured beyond the possibility for repair. Their long lifespans are helped by their decade and even century-long torpor cycles, adaptations to surviving poor environmental conditions and even being frozen thanks to the restriction of oxygen and nutrient delivery to essential organs. Infected organisms will be neurally modulated by the virus and present varying degrees of hematophagic tendencies. Appropriate anatomical adaptations will follow, including the formation of dental plates similar to those of Dunkleosteus, with cushioned plantar surfaces, retractable, keratinized claws, and stiff hooked hairs, helping them become better predators. This behavior will also be helped by the reinforcement of the zygomatic arches, providing attachment for powerful jaw musculature and the formation of a long proboscis from the tongue, with the gastrointestinal tract being shortened and repurposed to process blood, being capable of swelling when fully fed. Excretion and reproductive structures will be replaced by a cloaca. Highly developed olfactory bulbs, extended hearing sensitivity, and electroreception will allow for the detection of muscle activity in both prey and rival colonies. Nictitating membranes and tapetum lucidum-like structures will be formed to optimize low light acuity, but this increases internal light scattering, causing reflections to be perceived as intense visual noise, something called mirror blindness, leading to temporary cortical suppression of occipital lobe activity. As such, they will avoid and withdraw from mirrors and polished surfaces. Furthermore, these adaptations will make them susceptible to UV-induced damage, and direct sunlight can cause sluggish locomotion, thermoregulatory strain, accelerated dehydration, and dermal sensitivity, which they avoid by resting in the shadow and initiating torpor upon exposure to light. While this covers the general alterations associated with the holobiont, varied phenotypes exist due to a very important fact. Homo sapiens morbus schematicus tends towards the formation of eusocial hives with different castes, their differentiation being based on nutrient availability, colony size, prey density, and host condition. Lower types, or L types, are androgynous drones, primarily focused on hunting and host acquisition, exhibiting predominance of fast-twitch muscle fibers that allows for sudden bursts of speed, permitting short, intense, and well-coordinated predatory excursions. They have limited reproductive autonomy and lifespans of around 400 to 600 years, but great phenotypic diversity, with some strains even developing wing-like patagia. Higher types, or H types, are a dominant, reproductive queen-like caste, leading the colony through chemical cues and utilizing hormonal redistribution for caste-specific morphogenesis and reproductive oversight. Their bodies are adapted to endurance and stealth, and are much longer lived, usually having 2 to 5,000 year lifespans, and present much greater alterations that differ a lot between variants. Most amazingly, H-types will enter a cannibal morph whenever they detect another H-type from a competing hive. This detection works through the dispersion of toxic compounds, which can be lethal to foreign colonies, degrading their HIRC cells. This cannibal morph is intended for intraspecific conflict, characterized by hypertrophy of the limbs and elongation of the metacarpal's interruptorial hooks, dermal plate expansion forming pectoral armor, gliding membranes, and extremely heightened aggression, thus being used to rid the area of competition and optimize the resource and space availability. A final caste that only arose 120 to 150,000 years ago is the Lilitu, which acts as a reproductive and regulatory queen within colonies, their development being triggered by colony resource collapse, prolonged war between hives, and extended famine. An estrus-like reproductive state will be induced by pheromonal signaling from H-types following successful kills. By fusing drone-infested blood with their own spores, Lilitu can fertilize progeny, allowing for subsequent colony expansion, as well as inducing mild infection states through repeated low-volume blood exchange. Another of their main functions is rearing and caring for the fledglings, and overseeing caste assignment through endocrine control, including the strategic deployment of H-types, thus improving the colony stability, as well as using pheromone signals to direct and coordinate the colony, hunts included. As part of its adaptations, the Lily 2 presents highly specialized endocrine and neurochemical modulation and pheromonal output. Morphology-wise, Lily 2 retain a highly humanoid appearance, even including some secondary sexual traits and hair, and show minimal dermal thickening. Less externally visible features are also present, such as a feeding proboscis, full oral plates, retractable claws, hypertrophy of masseter and temporalis muscles, and subdermal trophic laminae replacing adipose and lymphatic structures. Thanks to this appearance, the Lily 2 also acts as a mimetic caste, specialized in infiltration of human societies to control and groom potential new hosts. This microsymbiont system was originally transmitted to human hosts from microchiropteran bats, owls, and thalids, organisms in which the symbionts evolved before first infecting mankind. It is likely the first fully stable holobiont appeared in the late Pleistocene, in Southeast Asia, its appearance being termed the Lamashtu event. According to paleogenomic modeling, this colony developed on a female host, likely predating Homo sapiens. From this point, the interplay between the three elements that compose vampires gave way to extreme morphological, ecological, and physiological diversity, with many more folkloric variants based on sightings and regional variations. Let us begin by referring to the Nosferat, an Eastern and Central European clade, the name itself derived from Old Transylvanian word Nosferat. This is the earliest divergent form recognizable as an ancestral phenotype, the rootstock from which all later, more stable lineages evolved. This clade presents multi-layered eusociality with strong selective pressure for group survival, with some megacolonies exceeding 12,000 individuals. Adaptations to this lifestyle include an enhanced pheromone reception for improved communication and coordination. They even have a corpse stench signal, which warns other members of their hive if an individual has been wounded. Their hives are usually formed underground, with the gnosis being very well adapted to such a lifestyle, presenting a lower metabolism that allows greater population accumulations in limited spaces and preferring access to substrate water that allows for the dispersion of protozoan cysts through marshes and floodplains, especially in areas with high host density. Behaviorally, Nosferat are unstable and show rabies-like symptoms, with erratic aggression and compulsive hematophagy, despite their adaptations to the diet being deficient. Still, they are as lethal as can be, and quite effective ambush predators. Physical alterations are quite extensive. The skull is thickened and hypermineralized, with extreme craniofacial reduction, and their oral plates are capable of crushing bones and severing limbs almost instantly. Bone plates are particularly broad on the brow and forearms, special adaptations for underground combat within tunnels and galleries. Aronization leads to elders becoming semi-quadrupedal during combat, and blood crops are formed to help transport blood to the hive. In the case of H-types, alterations are even more extensive, with expanded thoracic plates, blade-like raptorial middle fingers, and a cervical hinge that makes the head protrude forwards. Root-like pseudopods even allow a detached limb or head to be reattached. Then we have the Carpathian strigoi, a clade that split around 3.1 to 3.4 million years ago as they adapted to isolated forests and alpine regions with harsher environmental conditions and lower food availability, becoming better adapted to the cold than most vampires. Due to the conditions they live in, eusociality has been severely diminished, with hives having been replaced by much smaller nests or even solitary individuals. Some vestiges of eusocial behavior remain, including the retention of stable L and H types, the latter being much smaller and less reproductively hypertrophic than in other clades. Their violent behavior, however, serves perfectly in protecting and retaining their territories. Strigoi prefer isolated places to nest, such as caves or abandoned man-made structures, allowing the Strigoi to remain near available prey. These fearsome endurance hunters present the sharpest oral plates of all, and with their prey immobilized, they will prioritize superficial arteries to feed, later using their long proboscis to extract bone marrow and tap into deeper arteries. In this clade, skeletal ironization is linked to dominance hierarchies, and they present a notable red eye shine. While their adaptation to the cold makes them susceptible to heat paralysis, they seem more tolerant to the sunlight than most known clades. Further along this evolutionary tendency, we can find the wraiths, a clade that has discarded eusociality in favor of solitary hunting. In sharper contrast with other clades, wraiths are short-lived and present much more unstable behavior. While the extremely developed pinnae of wraiths allow them a greater auditory range and help them detect prey at greater distances, and even as their gliding membranes allow for greater mobility, the aforementioned behavioral instability, as well as their skull-like, bright white face, make them very easy to detect. This is compounded by their solitary life, which means this clade cannot depend on the aid of their hive to acquire prey. All of this resulting in the wraiths having to rely on prey that is easier to hunt, including the sick, the elderly, and even children. This has, of course, led to this clade having a very poor reputation among human populations when compared to other vampires. The Moroi, in contrast, have a much easier time blending in with humanity in order to hunt, as, unlike the more extreme alterations seen in other clades, Moroi present an external appearance that is much closer to that of the original host, and have been known to even wear clothes. This appearance allows them to pass as humans, at least, that is, at a distance, or under the cover of the night. While their androgynous look and pale, colorless hair would only arouse suspicion in people who are, well, already likely to suspect most people anyways, the human guise of the Moroi will fall apart the moment a potential prey or host takes a good look at their veiny, corpse-like skin. At this point, the Moroi will have mere moments to incapacitate and feed on their prey. With this out of the way, let us talk about two so-called proto-vampiric forms that arise from incomplete protozoan colonization or retroviral-only exposure, providing insights into the host pathogen dynamics of these vampires. Vampires arise from early pregnancy infection, with a pregnant host becoming infected before organogenesis. The protozoan spores will only partially integrate into the embryonic tissue, creating a mosaic of healthy and infected cells and causing the remodeling of the body to be more limited. This can be appreciated in the degree of muscular enhancement and skeletal ironization, varying degrees of eyeshine and night vision, and subtle dental plates, with actual hematophagy varying wildly from individual to individual. Ciliary circulation is partial, and they also present a marked immunity to pheromonal command, making them dangerous and potentially predatory to other vampires and hives. Furthermore, their very common sterility makes them evolutionary dead ends. Isolated from vampires and humans alike, they will tend to stay away from both, limiting themselves to liminal niches. The Upior, unrelated folk taxa such as Draugr or Jiangsu, further apart, are characterized by an exclusively retroviral infection, without protozoan colony establishment, usually due to the host's immune competence. As a result, little to no tissue differentiation or remodeling will be observed, including minor skeletal thickening and ironization, partial proboscis formation, and an incomplete ciliary network, with the cardiovascular and respiratory systems being retained. Heightened aggression and predatory instinct are observed, but the limited sensory enhancements make them more opportunistic feeders than active predators, and they do retain an instinctive avoidance of pheromonal signals from H-types. While not viable as a continuation of the full holobiont, Upior serve as vectors for retroviral propagation. The historical presence of vampiric hominins is corroborated by archaeological remains, including ironized and modified skeletons showing anatomy consistent with that of infected colonies, historical records, and indirect ecological markers, as well as evidence of ritualized attacks, territorial chemical markers, and cannibal morph encounters that align with modern biological observations. It is unquestionable that these organisms had a profound influence on human folklore and myths, creating a widespread oral and written tradition that often blended observation with mythological embellishments, leading to a diversity of cultural practices intended to deal with the presence of these extremely dangerous predators. And that's it for Speculative Biology look into a new brand of vampires, as commissioned by Jenny Wolf. We've met more than a couple vampires in our channel in the past, and now we return to the general concept of them with this idea, which reunites a bunch of mythical and folkloric vampires into a single unifying concept, similar to our earlier episode on werbeasts. The idea of making them the result of an infective process is nothing new, but the use of multiple symbionts and the extensiveness of the biological details Jenny provided gave me quite a bit to work with. And while the more humanoid designs were a bit out of my comfort zone, people, fellas, dudes, why are y'all so hard to draw? Working on them was still a ton of fun, with the slight distortions to the human figure being as fun to work out as always. Anyways, I've been yapping long enough, so I hope you guys enjoyed this episode. There's been a lot of love for vampire lore overall, so I hope this helped scratch that itch. And as always, huge thanks to our researchers and research associates who support us through Patreon and YouTube memberships. Remember, you too can join in if you want to support our channel and you have a couple extra bucks laying around. This will give you access to early looks at all of our creatures and videos, and you can even help us mold them into shape as we work on them. Or you can also like, subscribe, or write a comment telling me any type of creature you would like me to give the Spec Evo treatment in the show. Any of those really help the channel a lot. Thank you all for watching, and see you next time on the Speculative Wildlife Research Center.